Hello, this is Sir Alex once again, and you are here to learn about the midline theorem. It states that the segment that joins the midpoints of the two sides of a triangle is parallel and half as long as the third side. We have triangle LAN, and we have the midpoints E and R. Midpoint E is the midpoint of side LA, and midpoint R is the midpoint of side AN. If we are to join these two midpoints, and we will draw a line segment, we form the mid-segment ER. The theorem tells us that this mid-segment or this midline ER is half as long as LN. This means that side LN, or the third side of the triangle, is twice as long as the mid-segment ER, or ER is half as long as the third side LN. Now let us write it in an equation. Mid-segment ER is equal to the 1/2 of the measure of side LN, or side LN is equal to twice the measure of mid-segment ER. The theorem also tells us that the mid-segment ER is parallel to the third side LN. This means that the interior angles formed along these two line segments, angle E and angle angle E and angle L are equal. Also, we can say the same thing about the angles R and angle N. Angle R and angle N are also equal. Why? Because the mid-segment is parallel to the third side LN. Now let us write it into an equation. The measure of angle E is congruent to the measure of angle L. At the same time, the measure of angle R is also congruent to the measure of angle N. Now we have established the relationship of the mid-segment to the third side of the triangle, and we have also shown that the interior angles formed are also equal. But what about the two line segments formed on each of the two sides of the triangle? From the figure, we can see that the midpoint divides or separates a side into two equal line segments. For example, in side LA, we have the line segment LE and the line segment AE. We can say that these two line segments are congruent, so we will have line segment AE is congruent to line segment LE. We can also say the same thing on the second side. Line segment AR and line segment RN is formed because of the midpoint R. These two line segments are also congruent. The line segments formed on each of the two sides of the triangle are congruent because of the midpoint. Now begs the question, how and when do we use the midline theorem? What is its purpose? What is its function? We will see in the following examples. For our first example, we are asked to find x. The given is that mid-segment ER, the measure of mid-segment ER is equal to 2x minus 4, and the measure of the third side, the side LN, is equal to 3x plus 19. And from these two given, we will look for the value of x. Going back to the theorem, it tells us that the mid-segment is half as long as the third side. So mid-segment ER is 1/2 the measure of side LN. So the value of our ER in this example is 2x minus 4. And the value of our side LN is equal to 3x plus 19. So that is our first equation. Now we are going to use basic algebra in order for us to find the value of x. Now our goal here is to cancel 1/2 on that right side so that 3x plus 19 will be left. So we are going to multiply the whole equation by 2. So the left side will become 2 times 2x minus 4 and the right side will become 3x plus 19. The 1/2 disappeared because we multiplied it by 2. So 1/2 is cancelled on the right side. Here we have 2 on the left side. 2 multiplied to 2x minus 4. So it becomes 2 times 2x is equal to 4x, and 2 times negative 4 is equal to negative 8. So we have 4x minus 8. We will just copy 3x plus 19. Now we will combine like terms. We will transpose 3x to the left side. It will become 4x minus 3x. And we will transpose negative 8 into the right side. So it will become 19 plus 8. So our x will be 19 plus 8 is equal to 27. So our x is equal to 27. Now we have the value of x. Let us substitute the value of x to find the measure of mid-segment ER. Mid-segment ER is equal to 2x minus 4. Our x is 27. 2 times 27 is equal to 54. 54 minus 4 is equal to 50. So mid-segment ER is equal to 50. Now we are going to substitute the value of x to ln. So we are going to multiply 3 by 27. 3 times 27 is equal to 81. 81 plus 19 is equal to 100. So the value or the measure of side ln is equal to 100. Again, our x is equal to 27, ER is equal to 50, and ln is equal to 100. Let us move on to the next example. For our second example, we are asked to find AR. This is our line segment AR. The given is that the value of the measure of AR is equal to 3x minus 1, and the value of the measure of line segment RN is equal to 2x plus 8. The theorem tells us that because of the midpoint, this side AN is formed into two equal line segments, line segment AR and RN. So we can conclude that line segment AR is congruent to line segment RN. It just follows that 3x minus 1 is equal to 2x plus 8. From this equation, we can now solve the value of x, and in consequence, we will find the value of side AR. So let us first look for the value of x. We will now combine like terms, and we will transpose 2x into the left side. So this will become 3x minus 2x. We subtracted 2x from this side, and we also subtracted 2x in the left side. Now we will transpose negative 1 into the right side. So we will add 1 in the left side so that negative 1 will be cancelled. So our value of x is equal to 9. Now we can substitute the value of x, which is 9, into the given measure of AR. AR is equal to 3x minus 1. So 3 times 9 is equal to 27. And 27 minus 1 is equal to 26. So side AR is equal to 26. Since side AR is congruent to side RN, side RN is also 26. For our third example, we are asked to find the value or the measure of side LA. The given is the line segment LE is equal to 2x plus 7, and the line segment AE is equal to 3x plus 2. We know that these two line segments are congruent. Line segment LE is congruent to line segment AE. So it follows that 2x plus 7 is equal to 3x plus 2. Let us rewrite the equation so that we will have x on the right side. 3x plus 2 is equal to 2x plus 7. Now, we will transpose and combine like terms. In the right side, it will become 3x minus 2x. And on the left side, it will become 7 minus 2. So our value will become x is equal to 5. We have now our value of x. We will substitute our value of x in the given 2x plus 7. 2x plus 7 is the given value of line segment LE. Line segment LE is equal to 2x plus 7. So we have our x is equal to 5. So 2 times 5 is equal to 10. Plus 7, we have 17. So the value of line segment LE is equal to 17. We can just multiply 17 by 2 in order for us to get the whole measurement or the whole value of side LA. 17 times 2 is equal to 34. So our side LA is equal to 34. Let us go into our fourth example. For our fourth example, we are asked to find the measure of angle L. Angle L is equal to 3x plus 12, while angle E is equal to 2x plus 23. Going back to the theorem, it tells us that these two angles are similar or equal in measure. These two angles are congruent. Why? Because line segment or mid segment AR is parallel to the third side LN. So we now have the measure of angle AER is congruent to the measure of angle ELN. We can also express it, or we can also write it as the measure of angle E is congruent to the measure of angle L. The value of our angle E in the given is 2x plus 23, while the value of our angle L in the given is 3x plus 12. I'm sorry, this should be a symbol of equality, not a symbol of congruence. There. 2x plus 23 is equal to 3x plus 12. Now we will use simple algebra. (3x minus 2x is equal to 23 minus 12. So the value of our x is equal to 11. We will now substitute this value of x, which is 11, into the given 3x plus 12, so that we can get the exact measure or the exact value of angle L. So we have 3 times 11 plus 12. 3 times 11 is 33. 33 plus 12 is equal to 45. So the measure of our angle L is equal to 45. Let us go to our final example. For our fifth and final example, we are asked to find AR. Our given, we have segment AE and segment RN. It is shown in the figure that the two segments are congruent. Segment AE is congruent to segment RN, but we are asked to look for AR. By the theorem, we know that segments AR and segments RN are congruent because of the midpoint R. By transitive property, we can also conclude that segments AE and segments AR are also congruent. segment AE and segment AR are congruent. The value of our segment AE is equal to 4x plus 9, while the value of our segment RN is equal to 5x minus 1. Since the two segments are equal or congruent, it follows that 4x plus 9 is congruent to 5x minus 1. By using basic algebra, we can look for the value of x. So 5x minus 4x is equal to 9 plus 1, which is 10. So the value of our x is equal to 10. We can now substitute 10 to 4x plus 9. 4x plus 9 is equal to 4 times 10 plus 9. 40 plus 9 is equal to 49. So our side AE is equal to 49. So since AE and AR are congruent, they have equal measure. So if AE is 49, AR is also 49. So we have the value of our segment AR. AR is equal to 49. As you can see, all of our 5 examples using the midline theorem. That concludes our lesson. Hope you learned something new today, and thank you for watching.